Hello everyone, welcome to the part 4 of the geometry series. In the previous part, we looked at the various formulas of finding the area of a triangle. So, in this part, we are going to look at the various centers of a triangle. Alright, so let's start discussing. Okay, the first center of a triangle is called the incenter. Okay, so let's look at some of the properties of incenters. Incenter is the center of the inscribed circle. Okay, the in circle of the triangle. So if the triangle ABC, the inscribed circle is this one, right, and the center of this circle is called incenter. It is the point of intersection of the angle bisectors of the triangle. So that means if you join all the three angle bisectors, you will get the incenter at the point of intersection of those three angle bisectors. Okay, so this is a very important property. Let's look at what is the radius of a circle. So we know from the area that area of a circle is small r into small s, where small r is the in radius, and this small s is the semi-perimeter. So from that formula you can calculate the in radius if area and perimeter is given. Okay, so r is equal to a upon s. Alright, let's talk about the second center known as the circumcenter. The circumcenter is the point of intersection of the perpendicular bisectors of the triangle. Okay, so the circumcircle, this is the circumcircle circumscribing this triangle. That means all the 3 points of the triangle are lying on the circumference of the circle. So that circle is called circumcircle. And what about the circumcenter? Circumcenter, you join all the perpendicular bisectors. You join all the perpendicular bisectors. Their point of intersection is called circumcenter. So now here you can see that the circumcenter can be within the triangle, or it can be outside the triangle as well, right? So the circumcenter can be inside or outside the triangle, right? Let's talk about orthocenter. Orthocenter is the point of intersection of the altitudes. Okay, so it is the point of intersection of the altitudes, right? Altitude is the line which is perpendicular to the opposite side, right? Altitudes, and the intersection of all the three altitudes will give me the orthocenter. Okay, orthocenter. So here as well you can see that the orthocenter can be within the triangle, or it can be outside the triangle as well, right? So orthocenter can be outside the circle. All right, in case of a right angle triangle, the orthocenter is at the vertex of the triangle. So this is the orthocenter in a right angle triangle, right? In case of acute triangle, the orthocenter lies inside the triangle. In case of obtuse, it lies outside the triangle. And in case of right angle triangle, it lies on the triangle, that is on one of the vertex. Okay, so let's talk about the fourth center called as centroid. Centroid is the point of intersection of the medians. So what are medians? Medians are those lines which joins the vertex to the bisector of the opposite side, right? So bisector of the opposite side. So this is called a median. A median bisects the opposite side. Okay, so the intersection of all the medians will give me the point called centroid. Okay, also there is an important property that this centroid divides the median in the ratio 2:1. That means if A, if this is A, this is B, this is C, if ABC is the triangle here, and AD is the median, and let's represent centroid with G, right? Let's represent centroid with G. That means AG upon GD, AG upon GD is equal to 2:1. 2:1. That is, a centroid divides the median in the ratio 2:1. Also, a median divides the triangle into two triangles of equal area. Right? If AD is the median here, then the area of this triangle is equal to the area of this triangle. Right? The area of this triangle is equal to the area of this triangle. Right? That means the area of all these 6 triangles here, are equal. Right? In case of an equilateral triangle. Okay. Centroid is the geometric center of a plane figure. Okay. Now let's look at Euler line. What a Euler line is? The line that passes through the orthocenter, the circumcenter, and the centroid. The line which passes through the orthocenter, the circumcenter, and the centroid is called the Euler line. Alright. So this line which passes through the orthocenter, centroid, and the circumcenter is called as Euler line. Alright. So now we are done with the concept of the centers of a triangle. Let's quickly revise it first and then we'll solve some questions. Okay. So in center is the point of intersection of angle bisectors. Alright. In center is the point of intersection of angle bisectors. What about circumcenter? Circumcenter is the point of intersection of perpendicular bisectors. Alright. Perpendicular bisectors. Orthocenter is the point of intersection of altitudes, and centroid is the point of intersection of medians. Right? And Euler line is the line that passes through the orthocenter, circumcenter, and the centroid. Alright. So now we are done with the concept of the centers of the circle. Let's solve some questions. Okay. So this question is from CAT 2019 paper. Let's look at the question. In triangle ABC, medians AD and BE are perpendicular to each other. Okay, so let's draw a triangle first. This is triangle ABC. Alright, this is triangle ABC. This is median AD. This is A, B, and C. This is median AD. There is also another median BE. And these two medians are perpendicular to each other. That means this is perpendicular to BE. Right? So now we know that the intersection of the medians is called the centroid. So this point is centroid, and the lengths of AD and B is also given. The length of AD is 12. Length of BE is 9. Right? And we have to find the area of triangle ABC. Alright. So this point is called the centroid. Right? We know that the centroid divides the median in the ratio 2:1. That means AD is divided in the ratio 2:1. That means AG is to GD is 2:1. The total length is 12. That means AG is equal to 8. AG is equal to 8, right, and GD is equal to 4. GD is equal to 4. Alright. Okay, let's look at triangle ABE. Triangle ABE. Let's look at triangle A, B, and E. Let's look at triangle ABE. Alright. So the area of this triangle is half base into height, right? That means we know that AG is perpendicular to BE, right? AG is perpendicular to BE. That means this is the base, this is the height. So we know the base as well as the height. So we can find out the area of this triangle. So that is equal to half into BE. BE is equal to 9. Half into 9, right, into AG. AG is equal to 8, right. That means area of triangle ABE is equal to 9 into 8 is 72. 72 by 2 is 36. So the area of triangle ABE is 36, right. The area of this triangle is 36, and we know that a median divides the triangle in two equal halves. So if this is 36, the area of this triangle is also 36. So the total area of triangle ABC is 72. So I hope this is clear to everyone. Let's look at the next question. The next question says triangle ABC, angles A has 60, angle A is equal to 60 degree, angle B is equal to 70 degree. Okay. Let's draw a triangle. Okay. Triangle A, B, C. Triangle A, triangle B. Triangle A, B, and C. A is equal to 60 degree. A is equal to 60 degree. B is equal to 70 degree. Alright. That means C must be 50 degrees. C must be 50. Right. 60, 70 and 50. So now the incenter of this triangle. So let's draw the in circle. The center of that circle is called in circle. That is called in circle. Alright. The center, let's say that this is the center of this circle. Alright. The in center is called I. The in center is denoted by I. So we have to find the angle BIC. Alright. So we know that in center is nothing but the point of intersection of the angle bisectors. So the point of intersection of angle bisectors. So let's join the angle bisectors. So B, D and CE are the angle bisectors. That means this is half, so that means this angle is 35 degrees. Half of angle B is 35 and half of angle C is 25 degrees. Right. So in triangle IBC, this angle is 35, this is 25. Then the value of angle BIC is equal to 180 minus 35 minus 25, right? So 35 plus 25 is 60, 180 minus 60 is 120. So the angle BIC is equal to 120 degrees. So I hope this is quite clear. Let's look at the next question. Right. What is the distance between the orthocenter and the circumcenter of a triangle whose sides measure 24 centimeter, 26 centimeter and 10 centimeter. Okay. Just by looking at the sides, just by looking at the sides, we can we can we can say that the triangle is a right angle triangle. How? When you add 24 square, when you add 24 square and 10 square, when you add 24 square and 10 square, you get 26 square. That means, as this is satisfying the Pythagoras theorem, this is satisfying the Pythagoras theorem, right? 24 square is 576, 576. 10 square is 100, right? And 26 square is 676. So 24 square plus 10 square is 26 square. That means this is a right angle triangle, right? This is a right angle triangle. So this side is 24, this side is 10, alright, this side is 10, and this one is 26, alright. So now let's read the question. We have to find the distance between the orthocenter and the circumcenter. Okay. We know that the orthocenter of a right angle triangle lies on the vertex. So this point is the orthocenter itself. So this is O. Okay. What about the circumcenter? Since this is a right angle triangle, the circumcenter will lie at the midpoint of the hypotenuse. So this midpoint of the hypotenuse is the circumcenter C, right? Circumcenter C. So if the total distance is 26, half of it is 13. That means the radius of this circle is 13. So the distance between the orthocenter and the circumcircle is the radius itself. That means 13 centimeter. 13 centimeter. So I hope this question is also clear to everyone. So with this, we are done with the centers of the triangle. In the next part, we will look at some important theorems of triangles. Thank you. So this is the fifth part of the geometry series, and in this part we'll be looking at some of the important theorems related to triangles, and also will at the end of the video will solve some questions based on those theorems. So let's start. Okay, the first theorem is the angle bisector theorem. This is a very important theorem. It has also an extension which is for external angle bisector theorem. This is for internal angle bisector. Let's read what it states. Angle bisector theorem states that the angle bisector of an angle divides the opposite side internally in the ratio of the sides containing the angles. So it means that suppose if ABC is a triangle and AD is the angle bisector, these two angles will be equal, right? These two angles will be equal. Then the ratio of B upon C, B is to C, is equal to N is to M. I mean, this angle bisector divides the opposite side in the same ratio as the other two sides. This is what the angle bisector theorem states. It is also true for exterior angle. When this angle in triangle ABC, when A is extended and this external angle is bisected by AD, it again satisfies the same ratio, that B upon C, that is AB upon AC, is equal to CD upon BD, right? CD upon BD. So this is the angle bisector theorem. Let's move to the next theorem. Okay, the second theorem is the Pythagoras theorem. We know in case of a right angle triangle, if one side is B, the other side is A, the hypotenuse or the third side is given by root under A square plus B square. This is the Pythagoras theorem. Right, this is the Pythagoras theorem. In CAT generally there are a lot of questions based on this theorem and also on Pythagorean triplets. So we'll look at Pythagorean triplets on a separate video. Right. Over here, let's look at only the theorem. Theorem number 3 is the Apollonius theorem. Yet again, this is a very important theorem. This is a very important. Apollonius theorem states that the sum of the squares of any two sides of a triangle, the sum of the squares of any two sides of a triangle is equal to sum of the median square and half of the third side square, right? So here you can see that AB square plus AC square, AB square plus AC square is equal to twice of the median square plus BM is what? Half of AC, half of BC square. So half the third side, square of half the third side. So this is Apollonius theorem. Okay. The fourth theorem is the midpoint theorem. Midpoint theorem states that a line segment joining the midpoint of two sides of a triangle is parallel to the third side and is half of it. So in this triangle ATV, R and S are the midpoints of AT and AB respectively, and RS is the line segment joining these two midpoints. So RS must be parallel to TV and RS will be half of TV. So this is the property of midpoint theorem. Okay, let's look at the fifth theorem, which is also called basic proportionality theorem. Basic proportionality theorem states when you draw a line parallel to the third side cutting the other two sides at 2 points, in this case DE is parallel to BC and it is intersecting AB at D and AC at E respectively. So it states that the ratio in which it divides AD is to DB and AE is to EC will be equal. So this is called basic proportionality theorem. So these are some of the very important theorems which we will be using while solving questions on triangles in CAT and other management entrance examinations. So let's look at some questions now. I hope all the theorems are clear to everyone. So it will get the things clear when we will solve some questions. So let's start off with the questions. The question here says, in the figure ABC is a right angle triangle at B. ABC is a right angle triangle, right angle at B. Okay. And AD is the external bisector of angle A. AD is the external bisector of angle A. Alright. If AC is equal to 17, BC is equal to 8. Find AD. Find AD. Okay. By using the Pythagoras theorem, we can find out the value of AB. AB will be how much? AB will be equal to under root 17 square minus 8 square, right? 17 square minus 8 square, 17 square minus 8 square is 225. This is 289, this is 64, so 225, which is equal to 50, right? So the value of AB is 50, and we need to find out the value of AD. For finding the value of AD, we must know the value of BD, right? So here we can apply the external angle bisector theorem, which states that when the angle bisector of an external angle bisects it, the ratio of AC is to AB is equal to BD. Sorry, the ratio of AC upon AB will be equal to CD upon BD, right? So let's assume the length of BD as X, right? So 17, as per external angle bisector theorem, 17 upon 15 will be equal to CD. CD is X plus 8. Upon BD, which is X, 17X is equal to 15X plus 120. So X is equal to how much? X is equal to 60, right? X is equal to 60. So this is 60. This is 15. We can apply the Pythagoras theorem to find out the value of AD. Let's apply the Pythagoras theorem here. So AD will be equal to root under 60 square plus 15 square, right? Taking 15 square to be common, 15 will come outside the under root, right? This will be how much? 4 square plus 1. Therefore, the value is 15 root 17. So, 4th is the correct answer. I hope this is clear. So, in this question, we have used Pythagoras theorem as well as the external angle bisector theorem. Okay, next question. Here, the question says triangle ABC is a right angled triangle. Okay, and AC is equal to 100. AC is equal to 100. Okay. Also, AD is equal to DE is equal to EF is equal to FC. So all the 4 parts are equal. So every part will be 25 25, right? Every part will be 25 25. We have to find the value of BD square plus BE square plus BF square, right? Okay. Since ABC is a right angle triangle and AC is the hypotenuse, right? AC is the hypotenuse. Suppose I draw a circumcircle circumscribing ABC, then E must be the center. As center lies on the hypotenuse, E must be the center. Therefore, AE is the circumradius, so is EC, and also BE is also the circumradius, right? The value of AE and EC is how much? 50, half of AC. Value of AE is how much? 50, right? Therefore, BE is also equal to 50. BE is equal to AE. Right, is equal to 50. Okay. So we need to write the equation for Apollonius theorem in the triangle ABE. Here we know that these two are equal. That means this BD must be the median. This BD must be the median, right? In triangle ABE, ABE, in triangle ABE, BD is the median. BD is the median, right? Therefore, applying Apollonius theorem, we'll get AB square, AB square plus BE square AB square plus BE square is equal to BD square twice of BD square plus DE square. D square, we know the value of DE is 25, so 25. Right? Similarly, in triangle BEC, the median is BF. BF is the median, as these two sides are equal, right? Therefore, applying Apollonius theorem yet again in this triangle, BC square plus BE square, BC square plus BE square is equal to twice of BF square plus FC square, which is 25 square. This is equation 1. This is equation 2. Adding these two, we get AB square plus BC square. AB square plus BC square, which is nothing but AC square, right? So AC square plus 2 times BE square, and the value of BE is 50. 2 times 50 square, 2 times 50 square minus 2 times 25 square minus 2 times 25 square minus 4 times 25 square is equal to BD square plus BF square. BD square plus BF square whole twice, right? So from here AC square, we know the value of AC is 100, and this 25 square into 4 is nothing but 50 square. So 2 times 50 square minus 50 square is 1 times 50 square, and this is 100 square, right? Therefore 100 square plus 50 square by 2 is BD square plus BF square. We have to add another BE square, which is 50 square, right? So 2500. So this is how much? 12500. 12500 upon 2, 12500 upon 2 plus 2500. So this is how much? This is 6250, 6250. 6250 plus 2500 is 8750. So this 3 is the correct answer. So I hope this question is also clear to everyone. So let's look at the next question. Okay. Here the question is a long one, but this is the simplest of this way. This 3 questions. The Olympics committee came up with a new rule. The flag of the gold medal winning team would be hoisted to the right AB at 5 meters. The flag of the silver medal winning team would be hoisted to the left PQ at height of 3 meters. The flag MN of the bronze medal winning team would be hoisted at the point of intersection of the line joining the top of each of AB and PQ to the foot of the other, as shown in the figure below. Okay, so we don't know the height of this MN, so let's take it as X. A and P are 8 meters apart. In a wrestling event, India won the bronze medal. Find the height at which the Indian flag was hoisted. Okay. So this question can be solved by using a similarity, right? As in case of, if I am taking this triangle, and this one, right? That is A, P, Q, and AMN. These two triangles are similar in nature. Right? Therefore, x upon 3, this is suppose A, this is B, x upon 3 is equal to A upon 8, or you can say A upon A plus B, right? Similarly, in triangle PMN is similar to triangle PAB. So we can say that x upon 5 is equal to B upon A plus B, right? Adding these two, what we'll get? We'll get x by 3 plus x by 5 is equal to 1. Therefore, 1 by x is how much? 1 by 3 plus 1 by 5. So this is a very important result which we need to remember for solving questions, right? This is a very important property. We need not derive every time we go through a question, so we need to remember this property. Okay, we can directly apply this 1 by x is equal to 1 by a plus 1 by b if the other two sides are given. If suppose this is p, this is q, we can directly apply the formula as 1 by x is equal to 1 by p plus 1 by q Okay, so let's find out the answer to this question. 5 3 SMS 15, 5 plus 3 is 8, so the value of x is 15 by 8, right? So with this we have solved the third question of this video series. Let's move to the next video. Thank you.